So there's a 20% chance that a soda bottle has a winning cap. I don't think they do this anymore, but if you buy a 6-pack of soda, what's the probability that you win something? So we don't have to calculate the probability that 2 out of 6 are winners, 3 out of 6 are winners. We want the probability that 1 or more are winners. So in shorthand probability notation, the probability that x is greater than or equal to 1, where x is the number of winning caps. Okay, we're asked to calculate the probability that there's 1 or more winning caps. And so there's a quicker way of doing this, because if you were to try to do that right now, you'd have to calculate the probability that there's 1 out of 6, plus the probability of 2 out of 6, plus the probability of 3 out of 6. It would take a long time, right? Instead, what we can do is we can say, okay, 100% means all the possible outcomes. We're going to subtract it by the probability that we have 0 winning caps, okay? Because 100% means you've got everything possible accounted for. Out of all the probabilities, like the probability of getting no winning caps, plus the probability of 1, plus the probability of 2, all the way up to the probability of 6 winning caps. If you were to add all those up, that's every possible outcome, so that's 100%. And if we take out the probability that none of them win, what we're left with is the probability that 1 or more of them are going to win. Okay, and so to calculate the probability that there's no winning caps, probability of losing going to be the probability of losing 6 times. So the probability of winning is a 20% chance, so it's 0.20. So the probability of losing is 80%, so 0.80. And then that's the probability of one of those losing. Because we're going to assume that all the caps are independent. Now, getting a winning cap on one doesn't change the chance of getting a winning cap on the other. That means we can calculate the probability of all 6 of them being losers by multiplying them together. That's from the independence rule. It's an extension of that basic rule. Okay, so if the probability of A and B are independent, then you can find the probability of both of them happening by multiplying the probability of just A happening as the probability of just B happening. It's for 2 events. The rule extends for 6 events. You can find the probability of losing all 6 of those by multiplying 0.8 times itself 6 times. And then, so if we do that, that's 0.80 to the 6th power. That's a quicker way of saying that. Something times itself 6 times. So I'm going to get a calculator. I'm going to type in 0.8 and raise it to the 6th power. So that's the probability that none of them win. Okay, so we want to plug that in here. So 1 represents 100%. The probability of none of them being winners is 0.262. So if we subtract that from 1, we have a 0.737 chance that at least one of them is a winner.